Welcome to a Quantubly video. This one's on context and how to put data in context so you don't misunderstand what's being presented. Or, another way around, it's about how to understand visualizations of data to ensure that you are not misrepresenting or misinterpreting the data. The human brain isn't very good at getting a whole heap of numbers as shown in the middle of this slide and making a pattern for them in your head. However, we're very good at looking at visualizations of data, as on the right hand side of this slide, and seeing patterns and understanding them. The other thing, people can use language to help misrepresent data. They can use the term average, anchor mean, mode, median, or the arithmetical average, the mean, to represent a data in context. And again, unless you understand what the word average means, if someone's presenting it, then you may actually put in data in the wrong context in your head when trying to understand patterns and trends. Line graphs, interesting. Make sure you understand your axes. Here, Facebook is showing that they can understand when someone's going to go into a relationship by the number of posts they make, and they show a very distinct difference and very distinct drop in the number of posts. But that drop is actually only 0.16 posts. It affects 16% of a post. That to me doesn't seem like a significant amount, yet the graph suggests it is. Taking that further, this graph shows a very similar thing, that we have growth from 20 to 22 across January to December on the graph on the left. And that looks like a very slow growth. However, if you change the axis to just go from 20 to 22 rather than 0 to 25, as in the left hand side, the growth looks exceptionally steep. Again, just putting the data in context can give two different messages. When comparing data in graphs, here we show President Obama and the number of pirates he's killed in his presidency compared to other presidents, and he looks like he's exceptionally good. However, if he's compared with other presidents before those in that sample I've just shown you, he's actually very poor. So make sure you show that the highs and the lows and the right averages when doing things in context. The other thing that comes up, and it's been quite popular on the internet lately, is correlation does not equal causation. Just because there looks like some kind of linear analysis and progression of data, that doesn't mean that the two things you are comparing are the same. Here we've got global average temperatures on the left and the number of pirates on the right, and the less pirates there are, the higher the temperature goes, suggesting that if we had more pirates in the world, then the temperatures would go down. So this obviously has no correlation, but it just goes to show that you can find patterns in data. So be sure that when you are comparing things, that you really make a distinction between causation and correlation. Pie charts are another personal issue of mine. Unless you're only comparing two things, pie charts are very difficult to understand. Much like numbers, you need a different way of representing the patterns, and here the bar charts show the patterns of the charts above us and how things differ, and things that aren't really clear just by looking at the pie chart. And finally, this is my perfect example of a graph. I love spaceships and Star Wars and things like that, and here we can clearly show that Boba Fett's Slave One ship is pretty much the same length as the Millennium Falcon. No numbers are used, no misinterpretations used, two models, two distinct spaceships, and I can see that they're exactly the same length. That's the perfect kind of graph. This was Quantubly. Hope you enjoyed that. Goodbye.